It's the one and only allocated reptile finally streaming again. Today we're going to be doing another Frightful Face stream, of course. Here's the thing I want to do. So I want to be able to have liquid physics in the game because I've pretty much done all the AI in the game, all the main mechanics. I just need to finish off cooking, and the only problems with cooking is doing some liquid soup stuff, and I just need to do some of those systems. And one of the main things I want to do is have water physics. So I was thinking, we have a circle or a small cylinder that's roughly the size of the pot, and say as you move your mouse to the left, it's gonna I don't know which way it will rotate, the water will probably, the inertia, so the water will probably go that way. So if you move the mouse to the left, the water's gonna slosh up this way, so I'm gonna rotate this little circle up here. Now the thing is, if you rotate it, the radius will change the same. So it would be like this, it would have a gap between the edge of the water and the pot. However, if we do some trigonometry and we rotate it, we can actually scale it up to the end of the pot on one axis using its local axis. So say if we rotate it, you rotate it like 40 degrees or something, you have, you don't know the radius, however this will remain constant because this is the center of the cylinder that remains constant to the side. So I would need to know what that constant is, so then we can do trig. And since we got the adjacent side here and we're trying to work out the hypotenuse, that is the cosine rule, I didn't write it down, but yeah, so adjacent over hypotenuse is cos. So since we know the angle and we know the adjacent, we can work out the radius. And since the radius, the diameter is 2 times the radius, that's how much we would need to scale it by, I believe. I don't know, might need a bit of fudge factoring there. So then, yeah, and then basically we want to spill the water too. So if you rotate it, you move your mouse fast enough, and the angle is greater than this angle. So this, okay, how do I explain it? It would be better if I had it drawn, but this angle here is another right angle triangle from this point but to the max point. So if the angle of the water tilt, we want some of it to spill, so we'll take some of the water. Then there's a min point, which would look like this right angle triangle, which will stop it from clipping through the pot and going out. Then this part's going to be a little more tricky when you're not holding the object and it has a rigid body which can just be moved around. The water is supposed to stay flat. 40 degrees, it's going to stay flat, so it's almost tipping over, and then when it's completely 90 degrees, it's going to spill. So yeah, that is the game plan. Let's get to it. Okay. Let me open up the unities. Oh man, it's taking a while. I'm skipping this song. This song's a bit of an L, I'm not gonna cap. Alright. Doesn't have a roof. I've just kept that hidden so I can... So anyways, I've already made the script. I haven't started it though. Scripts, it's in cooking mechanics, and it is non-jiggle physics, liquid wobble. Or could we do it in water content as well? Side duration, that can all stay. That's on the pot though. We'll just have it in its own separate script. Okay, we'll close these scripts down. Alright, let's start. So liquid wobble. First things first, I need to get a reference to the player's interaction system to see if they are holding the object. So interaction. And start, we will set that interaction is equal to find object of type interaction. Bang. So now we got a reference to that. So hold up, I forgot what the method is called. Interaction is picked up. That is a boolean. Is there a get? Yeah, no, it is picked up. Okay. If interaction dot is picked up. Let me just gotta double check, make sure it's the right thing. Picked up his tree. Yeah, that's what that is. So we would like to then execute another function, liquid wobble, or physics, I guess. Okay, so we'll call this from here physics. So we will need to store it in a vector. Hold on. Let me test this real quick. Grab the water, pull it up. Okay, so isn't it? Kind of forgot how yeah. I mean, it's kind of, and then it gets scaled up though as well. So let me just, this is pivot local. Yeah, so that's how I would like it to look, like when it's all rotating. Okay, gotcha. Should only be doing one X. Let me just test something. So we rotate it. It's going to need to be scaled up then. But then we're also rotating it, say, this way, per se. So this would also need to be scaled up. But that shouldn't affect it, right? I hope not. We'll see, we'll see. Alright, we'll get a vector 3. Vector 3 player input is equal to new vector 3 input dot get access with mouse X, I believe, and mouse Y And then we also want to do it for the movement too. Need to think here. Alright, we'll just do it for now. Or is this is more of a vector 2, I believe. Vector 2 input get access mouse mouse y. Or we can make this a vector 3 and just have 0. Alright. Now, do we times it by delta time? I can't remember. I think so, yes. Alright, we'll test. Transform. Oh my god, shut up, bro. Maybe we have another vector 3 called Euler original rotation, and this will be oh god rotation, and this will be equal to transform dot Euler angles. That's a vector. Shut up. This music's actually so annoying. I'm gonna put on rain. I'm sorry. I can't stand that. This music's so arse. In my opinion. That's much better. Alright, so dot Euler angle. So if we say transform dot Euler angles is equal to rotation plus plus player input times time dot delta time. And this will do bed mass. So it does the multiplication before, yeah. I'll just to make sure. I'm pretty sure it does bed mass, but I'll just put it in brackets just to make sure. Or do we want? I'll just do the whole thing. Okay. Let's see how that goes. I have no idea how it will go. So we'll put it on the water, liquid wobble. Oh no, because the class. Oh yeah, I changed the name, didn't I? Water wobble, liquid. Okay. Liquid. Alright. Just gonna recompile. And now we'll put that on the water. Bang. Interaction. Oh, we could just make a little note. Hide in inspector. Because that doesn't need to be seen. Alright. Well, okay, we'll try it now. Try it. Oh, Jesus Christ. Oh, okay. Whoops. I forgot to disable some of the monsters. Okay, we'll get rid of these two. Alright. Okay, now it should all be nice and safe in our restaurant. Okay. So What is the problem here? Mouse X is not a setup. Okay, what did I put for the player? I may be remembering wrong. Horizontal, maybe? Okay, we'll check. So it was in the camera movement. Mouse. Oh, it's a space, son of a. I knew it. Oh, I actually didn't, but. My bad. Okay, this may work now. Actually, I might want to do a quick thing in the script and have a reference to the public water content. Just so we can, you know, just for later. Because we probably will need that. Find objects of type water content. I don't know if I'll be able to get this done before. I'll probably go to bed at 11, but we'll see. Okay. Okay. Is. Wait. Hey, it is wobbling. Look at it go. Now it just needs to. Yeah, that's. And. Oh my god, Jesus. Alright. I might make this. We need to make this public speed. Public float. Rotation speed. And we'll set that to 5 maybe. Times rotation speed. That may work. Oh my god. Put it in the water. Do some random stuff around. Have a quick tour. Alright. Okay, it needs to be much, much, much higher, bro. It's 50. Why not? We'll see how violent it is. Oh, yeah, that's much smoother. Oh, yeah, okay. Yeah, that works well. Is that... Okay, so... Alright, and... Oh, God. Uh-huh. Now, how are we going to make it slowly go back to its original position? Mouse X. That is a bit of a problem. -1 maybe. Vector 3. Water rotation subtraction is equal to new vector 3 and this will be, put that as -0.9 the negative of the... Okay, so you can either get a negative value of a mouse or a positive. So it's going to be a scalar multiplied by this. It's going to have to be a negative scalar. Because if it's going in the positive direction, a negative make it go back down. But if it's like going in the negative direction and you're timesing a negative thing, so we positive and go back to that. Should work. So we'll make this maybe 1/2, so 0.5, negative 0.5 times, or okay, player input negative 0.5 times player input, and wait, can I not do that? F. Yep. Times player input and minus... Oh, this is kind of messy, no cap. Water rotation. We'll see how it goes. I really don't know. Not looking good so far. See, it's you know, it's moving. Up and down moves it left and right. Okay, maybe I'm thinking maybe this has to be that there. Make that 0. What? Oops, wait. So it's supposed to be another bracket? Oh, what? Why is that there? What the goof? Alright. Try that now. So there's gonna be a lot of maths required in this script. I already know it. It's not doing what I want it to do. I think it was better how it was. Maybe. Just maybe. Oh jeez, okay. It's gonna get real messy. Okay, player input is equal to game object transform direction, so we can make it local player input. Yeah. And we'll try that for the water rotation as well. Wait, no, because that's already... I don't know about this. We'll try it. Oh my god. Jesus. I'm not even gonna pretend like I understand why. Maybe not, then. Yeah. Okay. I'm gonna get rid of that for now. Hang on. Time of the rotation. Now, how do I make it decrease? What's the original rotation of the object? Is -90. I'm gonna move this up. That will do. So I just don't need to keep doing that all the time. Yeah, I'm pretty sure the problem is it should only do it. Hang on. Yeah, it's not gonna be perfect, is it? Okay, so we're gonna have to do it like one at a time. Can't mix. Okay, so the only way I know how to do this, okay, float x-axis is equal to input dot get axis mouse x float y-axis is equal to input dot get axis mouse y if okay float rot axis is equal, so we're gonna have to do a ternary, what's it called, a ternary variable, I don't know, x-axis greater than y-axis question mark, and then we sign the values x-axis y-axis. I believe that's how you do it. Rotation, transfer value, rotation. I don't know how to do this. It needs to be in a vector. Because then that shows the thing. Yeah, it might just have to be... Okay, it's a bit rough. If x-axis greater than y-axis, then transform of equal angles is equal to x-axis dot x plus. Oh my god, I'm struggling here. Jesus. New vector 3. We'll just do new vector 3. This isn't very good. Oh well. 0. Such rotation. So that might work. Oh, what the? And then it... Why does it do that? Debug.log x-axis. I honestly did not think this part would be that hard. I was incredibly mistaken. Oh shit. It doesn't go back. That's why. Yeah, no. Oh, that's really not... I thought it would have... Okay, we'll try get a raw axis. Get axis raw? Don't know about this one, but we'll try. Why isn't it? See, it works, like... I'm just not understanding. Oh my god, I'm such an idiot. Oh, okay. Alright, we need to make this positive somehow. You can always make something positive by timesing it by itself, I guess, and loads. Okay, times. Okay, no, it's just... How to make floats positive unity. Ah, absolute, that's right. Forgot about math F. Alright, now it shouldn't worry about positive or negatives. Okay. So it should rotate either way. There we go. That... Why? Why did it clip? Oh my god. Let's try that again. Okay. But then it gets a bit screwed up when I do that. Okay. And... okay, so this is where we have to do the angle stuff. What's the radius of this? Oh my god. That's... We'll have to work with local scales, I think. It's a problem. Okay. Private float radius. Original radius, maybe. Or just, no, just radius. And maybe we need original radius. Okay, so... Radius is equal to... Rate... is equal to 1/2 times, it doesn't really matter what axis we use, times game object transform dot local scale dot x, we'll say. What's wrong here? Double the F. And then we'll debug.log that. So we'll have to do a little bit of maths. Debug.log. Radius. So what is the radius? The radius is... is that the radius? That's the radius. Negative. Oh, why isn't... Can we just... positify it? That? How is that global? What? Center. Alright, what? Alright then. Alright, there we go. That's roughly the radius, and then it'll get, and it'll halve that to get the radius. So the radius is that. Okay. So when we rotate it, bang, we will do some calculations. Yes. So if we get the radius, wait, no, we need the radius and private float. Private float. Original radius, because that's how we're going to do the trig. Okay, so original. We'll set original radius to this. And then radius, the normal radius, will be equal to original radius. Okay, and then we need to change the radius. So we know the angle, we know the rotation. So yeah. Rotate it on the x-axis. And then do the... Okay, pause. How am I going to do this maths? So, we know the radius would be equal to... It is the original radius divided by... Okay, so... Adjacent over hypotenuse, that's cos. Cos theta is equal to adjacent over hypotenuse, which is the original radius, over the radius. So therefore the radius is equal to the original radius over cos of the angle. Over cos... How do you math f dot cosine? Yeah, cos of the transform dot Euler angles dot x, I believe. And that will give us the radius, and we'll debug all of that. So theoretically, that should change the radius based on the rotation, but I'm not sure yet. Fingers crossed. So it does seem to be increasing. I think that's good. So now we know the new radius, and the scale should be equal to 2 times the radius. Transform dot local scale dot y dot x is equal to 2f multiplied by the radius. Oh, you can't do that. Is equal to plus equal to new vector 3 radius or 2 times radius 0, 0, 0. Oh my god, I'm tired. I need to go to bed. So we will get out of this, and then hopefully, like from an outsider view here, we see that it changes. Hopefully the scale changes, hopefully. I mean, yeah, it had the right idea, I guess. Radius. Oh shit, dude, I don't know. Plus equals. Oh, maybe that's why. That could be why. Oh, what? I don't even know where the frick it is. Where is the water? Earth to water? Where is it, mate? Alright, I'm position. Oh, water. Where the frick is the water? Is it infinitesimally small? Oh shit. That's why. Yeah, that wasn't smart. Transform.localscale.y and then .z because I made it ridiculously small. My bad. So small that you can't see it. So please, please, can my math be correct? Please. Please, please, I'm begging you. Still not correct. Oh. Hmm. It. Oh man. I want to at least try and get this done before I go to bed. Okay, can I please like have the UI? Hello, what's going on? Thank you. So it's scaling it that way, and X is that way. Oh my god. Alright. So it's supposed to be on the Z then? Is that what's supposed to be happening? Local scale dot X. If I can't figure this out, then Ovel. Okay, please reset that. Reset that. Need mining. So if we rotate it on the X, then it needs to be scaled. Oh, can you stop? It needs to be scaled. Yeah, on the Z. Why? That's just so unnecessary, but okay. I don't know. This is really, really challenging. Like, it looks good there. Like, that is scaled perfectly. Like, doesn't get much better than that. Why is it? So what is changing? See the trigger. That doesn't. So this isn't changing. The water is though. Yeah, I'm not sure. I'm not I'm not sure at all. I don't get it, like, But at least it's only changing the Z scale. But then it's changing the rotation. Oh, wait a minute. Yeah, it's gonna change that as well. Oh, I don't know. Alright, I might need to, yeah, have a bit of a sleep over this one. Yeah, I really don't know what I'm gonna do about this. That is a problem and a half, but hopefully I'll be able to fix it later. Thank you for watching, and I'll see you in the next one. Goodbye.